Welcome dear audience, students and scholars. Here I am Dr. Amjad Ali. In this video we are going to discuss about the Mundell-Fleming model. Dear scholars, once Robert Mundell said that the world is still a closed economy, but its regions and countries are becoming increasingly open. The international economic climate has changed in the direction of financial integration, and this has some important implication for the economic policy. Dear scholars, when conducting monetary and fiscal policy, policymakers often look beyond their own country's border. Even if domestic prosperity is their sole objective, it is necessary for them to consider the rest of the world. The international flow of goods and services and the international flow of capital can affect an economy in profound way. Policymakers ignore these effects at their peril. In this video, we extend our analysis of aggregate demand to include international trade and finance. The model developed in this video is called the Mundell-Fleming model. This model has been described as the dominant policy paradigm for studying open economy, monetary and fiscal policy. In 1999, Robert Mundell was awarded the Nobel Prize for his work in open economy in macroeconomics, including this model. The Mundell-Fleming model is a close relative of the IS and LM model. Both models stress the interaction between the goods market and the money market. Both models assume that the price level is fixed and then show that what causes the short-term fluctuations in aggregate demand or aggregate income would happen. The key difference is that the IS and LM model assumed a closed economy, whereas Mundell-Fleming model assume an open economy. The Mundell-Fleming model extends the short-run model of national income and aggregate demand and IS and LM model by including the effects of international trade and finance. The Mundell-Fleming model makes one important and extreme assumption. It assumes that the economy being studied is a small open economy with perfect capital mobility. That is, the economy can borrow or lend as much as it wants in world financial markets, and as a result the economy's interest rate is determined by the world interest rate. Mundell's assumptions of a small open economy with perfect capital mobility will prove useful in developing a tech-able and illuminating model. One lesson from the Mundell-Fleming model is that the behavior of an economy depends on exchange rate system it has opted. Indeed, the model was first developed in a large part to understand how alternative exchange rate regimes work and how the choices of exchange rate regime can be set on monetary and fiscal policy. We begin by assuming that the economy operates with a floating exchange rate. That is, we assume that the central bank allows the exchange rate to adjust to changing economic condition. We then examine how the economy operates under a fixed exchange rate. After developing the model, we will be in a position to address an important policy question, that is, what exchange rate system should a nation can adopt. In this video, we construct the Mundell-Fleming model, and in following videos, we use the model to examine the impact of various policies. As you will see, the Mundell-Fleming model is built from the components we have used in our previous video, like IS and LM model, like aggregate demand model. But these pieces are put together in a new way to address a new set of questions. Okay, the key assumption, small open economy with perfect capital mobility. Let's begin with the assumption of a small open economy with perfect capital mobility. This assumption means that the interest rate in the economy R is determined by the world interest rate R static. Mathematically, we can write this assumption as R is equal to R static. This world interest rate is assumed to be exogenously fixed because the economy is sufficiently small relative to the world economy that it can borrow or lend as much as it wants in the world financial markets without affecting the world interest rate. Although the idea of perfect capital mobility is expressed with a simple question, it is important not to lose sight of sophisticated process that this equation represents here. Imagine that some event occurred that would normally raise the interest rate. So what happened to the economy? While talking about the key assumption, small open economy with perfect capital mobility, in a small open economy, the domestic interest rate might rise by a little bit for a short time, but as soon as it did, foreigners would see the higher interest rate and start lending to this country. The capital inflow would drive the domestic interest rate back towards R static. Similarly, if any event started to drive the domestic interest rate downward, the capital would flow out of the country to earn a higher return abroad, and this capital outflow would drive the domestic interest rate back up to R static. Okay, hence the R is equal to R static equation represent the assumption that the international flow of capital is rapid enough to keep the domestic interest rate equal to the world interest rate. So let's discuss the goods market and the IS static curve. The Mundell-Fleming model describes the market for the goods and services much as the IS and LM model does, but it adds a new term for the net exports. In particular, the goods market is represented with the following equation. We have here y is equal to c into y minus t plus ir plus g plus nxe. This equation states that the aggregate income Y here is the sum of consumption, investment I, and government purchases G, and the net exports here NX. Consumption depends positively on disposable income, that is Y minus T. Investment depends negatively on interest rate. Net export depends negatively on the exchange rate, here we have E. As before, we have discussed that we define the exchange rate in our previous video as E. So as the amount of foreign currency per unit of domestic currency, for example, E might be 100 yen per dollar. You can recall our previous videos when we have discussed that we can relate net export to the real exchange rate rather than the nominal exchange rate, the relative price of domestic and foreign currency. Okay, if E is the nominal exchange rate here, then the real exchange rate E equals EP over P static, where P is the domestic price level and P static is the foreign price level. Okay, the Mundell-Fleming model, however, assumes that the price levels at home and abroad are fixed. So the real exchange rate is proportional to the nominal exchange rate. That is, when the domestic currency appreciates and the nominal currency exchange rate rise, say from 100 to 120 yen per dollar, foreign goods become cheaper compared to domestic goods, and this causes exports to fall and imports to rise. Then the goods market equilibrium condition has two financial variables affecting expenditure on goods and services that we call the interest rate and exchange rate. But the situation can be simplified using the assumption of perfect capital mobility. So we have R is equal to R static. From this we can obtain our main equation, that is y is equal to c into y minus t plus I r static plus g plus nx e. So let's call this the is static equation. This equation we call it is static equation because previously we don't include the exports in our is equation. So here static reminds us that the equations, this equation hold the interest rate constant at the world interest rate are static. We can illustrate this equation on a graph and in which income is on horizontal axis and the exchange rate is on vertical axis. So let's see a graphical presentation for the is static curve. We have three parts of the graphical presentation here. The first, we have the net export schedule. We have net exports on x-axis. We have exchange rate E on y-axis, and we have a downward slope for the demand for the net exports. And at this point, we have that amount of net export with that exchange rate. Okay, by raising the exchange rate, an increase in the exchange rate, see we have here from E1 to E2, will lower our net exports and we have a decrease in our net export from NXE1 to NXE2. Let's draw the Keynesian cross. We have income output y on x-axis. We have expenditure on y-axis. We have 45-degree line for the actual expenditure. We have planned expenditure. We know that the intersection of the actual and planned expenditure will decide the equilibrium, and this is our national income Y1. Okay, by raising the exchange rate, we have a decrease in net exports, which will decreases our planned expenditure. So shift the planned expenditure downward. We have a downward planned expenditure curve. This will intersect our actual expenditure curve at this point, and we have a lower national income that is from Y1 to Y2. So let's draw the is static curve here. We have the 45-degree line for the actual expenditure. So let's draw the is static curve here. We have the income output on y-axis. We have exchange rate E on y-axis. Previously we have here interest rate as a variable which represents our y-axis. So if we take this exchange rate to this part, we have E1 with national income Y1, and by increase in exchange rate, we take this to this part, we have E exchange rate, and we have a depressing national income from Y1 to Y2. So by joining these points, this point and this point, we get the is static curve. So IS static curve summarize these changes in the goods market equilibrium. So here we have IS static curve. The IS static curve we have here derived from the net export schedule and the Keynesian cross schedule. In first part, as we have present here the net export schedule, an increase in exchange rate from E1 to E2. We have a lower exports from NXE1 to NXE2, and in the panel B we have a Keynesian cross, a decrease in net exports. So here we have a decrease in net exports, shifted our planned expenditure downward, and we have a reduced national income from Y1 to Y2. In the panel C we have a IS static curve which summarize this relationship between the exchange rate and income. The higher the exchange rate, the lower level of national income. So the IS static curves slope downward because a higher exchange rate reduces net exports, which in turn lowers aggregate income. To show how this work, the plan which we have discussed here, we combine the net export schedule and the Keynesian cross, and we get the IS static curve here. Okay, let's move towards the money market and the LM static curve. The Mundell-Fleming model represents the money market with an equation that should be familiar from the IS and LM model. We have real money balances, M over P is equal to R, or we can say the L function R Y. This equation states that the supply of real money balances, M over P, equals the demand LRY. The demand for the real money balances depends negatively on interest rate on this and positively on income. Okay, the money supply M is an exogenous variable controlled by the central bank, and because the Mundell-Fleming model is designed to analyze short-term fluctuation, the price level P is also assumed to be exogenously fixed. Once again, we add the assumption that the domestic interest rate equal the world interest rate, so we have R is equal to R static. Then we have M over P is equal to LR static Y. So let's call this LM curve or LM equation, LM static equation. We can represent this equation by graphically. So let's see a graphical representation. Here we have LM static curve. So we have income output Y on x-axis, we have interest rate R on y-axis. Sorry, we have a little mistake here, so we have removed the mistake with the price level. Here we have interest rate R on y-axis, and we have a upward sloping LM curve, and we have a fixed exchange rate because we have supposed that we have a small open economy, so domestic interest rate is equal to world interest rate. Okay, the money market equilibrium condition with presented here with LM curve, and the world interest rate here is representing the world interest rate are static, and we have the domestic interest rate R, and at this point we have that level of national income. And from the traditional LM curve we can drive the LM static curve. So in the panel B we have the LM static curve, and we have income output y on x-axis, we have exchange rate on y-axis, and we have a vertical shape of LM static curve, and this will determine the level of national income at this point. So this second panel of the graph, LM static curve, is vertical because the exchange rate does not enter in the LM static equation. Given the world interest rate, the LM static equation determines aggregate income regardless of exchange rate. So in this figure shows that how the LM static curve arises from the world interest rate and the simple LM curve, which relate the interest rate and income. So overall, this graph shows that the standard LM curve, which shows that we have the equation m over p is equal to L or y together with a horizontal line of interest rate. Domestic interest rate is equal to international or world interest rate. The here we have in the second panel we have get the LM static from the first panel. Okay, putting the prices together, according to the Mundell-Fleming model, a small open economy with perfect capital mobility can be described by two equations, that is IS static and LM static. Here we have y is equal to or we can say y is the function of c into y minus t plus IR static plus g plus nxe, and we have the real money balances. M over p is equal to LR static y. This equation here, the first equation describes the equilibrium in the goods market as we have done in our simple IS and LM model. The second equation here represents the equilibrium in money market. The exogenous variables are fiscal policy. Here we have G and T, and while talking about the monetary policy, and we have here M as exogenous variable and the price level P here, and the world interest rate are static. The endogenous variables are the income and the exchange rate. We have income and exchange rate are endogenous variable. So let's draw the Mundell-Fleming model graphically. We have income output on x-axis, and we have exchange rate E on y-axis. We have a vertical shape of LM curve, that is LM static, and we have a downward sloping IS curve, and we know that the intersection of IS and LM will present us the equilibrium income level and equilibrium exchange rate. Here we have the exchange rate. We have the equilibrium exchange rate at this point. So this graph of Mundell-Fleming model plots the goods market equilibrium condition IS static and the money market equilibrium condition LM static. Both curves are drawn holding the interest rate constant at world interest rate. The intersection of these two curves shows the level of income and exchange rate in the economy that satisfy the equilibrium both in goods market and money market. So technically this figure illustrates that these two relationship exist, that the equilibrium for the economy is found where IS and LM curve, here we have the IS and LM static curve, intersect each other. This intersection shows the exchange rate and the level of income at which the goods market and the money markets are both in equilibrium. With this diagram, we can use the Mundell-Fleming model to show how the aggregate income and exchange rate respond to change in policy. So this is all about the Mundell-Fleming model, and we continue the Mundell-Fleming model with further discussion, and we extend the Mundell-Fleming model in our coming videos. So see you with another video. Ciao.